Listen, everything you think you know about what planets look like is about to get absolutely destroyed. I'm talking complete planetary catfishing on a cosmic scale. You've seen those smooth, colorful spheres in textbooks, right? Yeah, forget all that. When you point humanity's most powerful telescopes at our neighbors in space, what you see will make your jaw hit the floor so hard it'll need orbital mechanics to bounce back up. Saturn isn't just the one with rings. It has a hexagonal storm at its north pole that's been raging for decades, and nobody knows why. Jupiter? Oh, you mean the planet with a storm so big it could swallow Earth 3 times over, and it's been going strong for at least 400 years? And wait until you see what Neptune actually looks like, because spoiler alert, it's not the gentle blue marble you've been lied to about. We're about to take a journey through the solar system, using the most insane telescopes humans have ever built, and I promise you, by the end of this video, you'll never look at space the same way again. Buckle up, because reality is way stranger than any science fiction movie ever dared to imagine. Let's kick things off with Mercury, and honestly, this planet looks like it went 12 rounds with Mike Tyson and then got hit by a bus for good measure. When the Hubble Space Telescope and ground-based observatories zoom in on this little rock, you're looking at what can only be described as the universe's most abused punching bag. Mercury is absolutely covered in craters, and I'm not talking cute little dimples, I'm talking massive impact basins that make the Grand Canyon look like a sidewalk crack. The most famous one is the Caloris Basin, which is about 1,550 kilometers across, and the impact that created it was so violent that it sent shockwaves through the entire planet and created weird rippling terrain on the exact opposite side. It's like someone punched Mercury so hard the bruise came out the back. Through powerful telescopes, you can see this planet has basically no atmosphere to protect it, so every space rock that comes knocking leaves a permanent scar. The temperature swings are equally insane. We're talking 430 degrees Celsius during the day and minus 180 degrees Celsius at night. Mercury looks like a gray, battle-worn veteran that's been sitting in the front row of a cosmic shooting gallery for 4 billion years, and honestly, it deserves a medal just for still being in one piece. The detail we can see now compared to even 20 years ago is mind-blowing, and it proves that the closest planet to the Sun is also possibly the most metal planet in our solar system, literally and figuratively. Now let's talk about Venus, which is basically that toxic ex who looks absolutely stunning from a distance but will literally melt your face off if you get too close. Through super telescopes like Hubble and the Japanese Akatsuki spacecraft, Venus appears as this gorgeous, creamy pearl with swirling cloud patterns that look almost hypnotic. The clouds create these beautiful Y-shaped patterns that rotate around the planet super fast, and from far away, you'd think this place is paradise. Wrong. So catastrophically wrong. Those beautiful clouds? They're made of sulfuric acid. Yeah, the stuff that will dissolve you faster than you can say, I should have stayed on Earth. The atmospheric pressure on Venus is 92 times that of Earth, which means standing on Venus would feel like being 900 meters underwater while simultaneously being roasted at 465 degrees Celsius. Through infrared telescopes, scientists can peer through those clouds and see the surface glowing with volcanic activity. Venus is basically one giant volcanic hellscape hiding under a pretty blanket. The wind speeds in the upper atmosphere reach 360 kilometers per hour, creating those mesmerizing patterns we see through telescopes. Venus proves that the universe has a twisted sense of humor. Make something look absolutely gorgeous, but turn it into the most hostile environment imaginable. It's like nature's version of a beautiful cake that's actually made of wasps and hot sauce. The level of detail we can observe now has revealed that Venus is far more geologically active than we thought, with possible active volcanoes reshaping the surface even today. Mars, oh Mars, you magnificent rust bucket! When you point something like the Hubble Space Telescope or high-powered ground observatories at Mars, you realize this planet is way more complex than just the red one. Sure, it looks red from Earth, but through super telescopes, you see browns, tans, ochres, dark basaltic rocks, and during certain seasons, brilliant white polar ice caps that grow and shrink like the planet is breathing. You can actually watch massive dust storms develop in real time through these telescopes. Storms so big they can engulf the entire planet and turn it into a fuzzy orange ball for months. The level of detail is absolutely insane. You can see Olympus Mons, the largest volcano in the solar system, which is so massive it's about the size of Arizona and towers 21 kilometers high. That's nearly 3 times the height of Mount Everest. Through powerful telescopes, you can spot Valles Marineris, a canyon system so enormous that it would stretch from New York to Los Angeles if it were on Earth. The canyon is up to 7 kilometers deep in places, making the Grand Canyon look like a decorative garden feature. What really gets me is that through these observations, we can see ancient river valleys, dried up lake beds, and geological features that scream, "Water was here." Mars had oceans, people! This desert world was once blue, and through modern telescopes, we're reading its geological autobiography in stunning detail. The seasonal changes are visible too. Dark slopes that appear and disappear, which scientists debate might be evidence of flowing water or just avalanching sand. Mars through a super telescope isn't just a red dot. It's a dynamic world with a tragic past and a story written across every crater and canyon. All right, buckle up, because we're about to talk about Jupiter, the absolute unit of our solar system, the planet that makes everything else look like adorable cosmic pebbles in comparison. When you aim telescopes like Hubble, the James Webb Space Telescope, or even high-end ground observatories at Jupiter, what you see is nothing short of spectacular chaos. First, there's the Great Red Spot, which is literally a hurricane that's been raging for at least 400 years and is bigger than Earth. Let me say that again, bigger than Earth. Through super telescopes, you can see this massive anticyclonic storm with incredible detail. The swirls, the turbulence, the smaller storms getting absorbed into it like some kind of atmospheric horror show. But here's the kicker. It's been shrinking. 100 years ago, you could fit 3 Earths in there. Now it's more like 1.5. Nobody knows why, and frankly, that's terrifying. The bands of Jupiter are equally insane. These are jet streams moving at hundreds of kilometers per hour, creating those distinctive stripes that look almost painted on. Through advanced imaging, you can see smaller white ovals, brown barges, festoons, and these chaotic regions where different atmospheric currents collide and create absolute mayhem. The colors aren't random either. Through spectroscopy, we can see they're caused by different chemical compounds, ammonia crystals, ammonium hydrosulfide, and possibly some organic compounds that give some regions that reddish-brown color. Jupiter's atmosphere is basically a 700-kilometer-deep chemical factory powered by insane weather systems. And if you think that's wild, the auroras at Jupiter's poles are hundreds of times more powerful than Earth's northern lights, creating these massive glowing circles that pulse with energy from Jupiter's massive magnetic field. Through infrared telescopes, you can even see heat rising from the planet's interior, revealing that Jupiter generates more heat than it receives from the sun. This planet is less like a gas giant and more like a failed star that decided to become the solar system's most dramatic weather channel instead. If Jupiter is the chaotic beast, Saturn is the elegant aristocrat of the solar system, until you look closer and realize this aristocrat has some seriously weird hobbies. Through super telescopes, Saturn is breathtakingly beautiful with its iconic rings. But the detail you can see now is absolutely mind-bending. Those rings aren't solid. They're made of billions of chunks of ice and rock, ranging from dust grain size to house-sized boulders, all orbiting in this impossibly thin disk that's only about 10 meters thick in some places, but over 280,000 kilometers wide. Through Hubble and other advanced telescopes, you can see gaps in the rings, like the Cassini division, created by gravitational resonances with Saturn's many moons. You can literally watch shepherd moons like Prometheus and Pandora sculpting the rings as they orbit. But here's where it gets weird. Saturn has a hexagonal storm at its north pole. Not circular, not oval, hexagonal. This thing is wider than two Earths side by side, and it's been rotating there for decades with these perfectly straight edges that seem to defy physics. Nobody fully understands how a fluid dynamic system creates a stable hexagon, but there it is, spinning away like Saturn decided geometry was cool. Through infrared and ultraviolet telescopes, you can see Saturn's atmosphere has similar banding to Jupiter, but more subtle. Creams, golds, and pale browns created by ammonia ice and other compounds. The planet experiences massive storms too, called Great White Spots, which appear roughly every 30 years, once per Saturn year, and create these huge bright eruptions that can wrap around the entire planet. Through powerful telescopes, observers have watched these storms develop, seeing lightning strikes thousands of times more powerful than Earth's lightning. Saturn's rings also do this beautiful thing where they change their appearance based on their angle to Earth. Sometimes we see them wide open, and sometimes they're edge-on and almost invisible. The level of detail we can observe shows that the rings have waves, ripples, and structures called propellers, where moonlets create patterns as they plow through the ring material. Saturn through a super telescope is like watching an elegant cosmic ballet, where the dancers occasionally break into geometric shapes for no apparent reason. Let's address the elephant in the room. Yes, the planet is called Uranus, and yes, we're all adults here, so let's move on and talk about how genuinely bizarre this planet is. When you observe Uranus through powerful telescopes, the first thing you notice is that it looks like someone knocked it on its side and it just decided to roll with it. Literally, Uranus rotates on its side with an axial tilt of 98 degrees, meaning its poles take turns pointing almost directly at the Sun during its 84-year orbit. Through supertelescopes like Hubble and the Keck Observatory, Uranus appears as this pale cyan sphere that looks almost featureless at first glance, like someone created a planet and forgot to add texture. But when you use the right filters and infrared imaging, you start seeing atmospheric features, faint bands, occasionally bright storms, and these weird dark spots that come and go. The color comes from methane in the upper atmosphere, which absorbs red light and reflects blue and green wavelengths back into space. What's fascinating is that despite looking so calm, Uranus has wind speeds up to 900 kilometers per hour in some regions. Through advanced observations, astronomers have spotted massive storms appearing in Uranus's atmosphere, particularly during its equinoxes when both hemispheres get sunlight. These storms can be as large as North America and appear as bright clouds that stand out against the otherwise bland backdrop. Uranus also has rings, but they're dark and almost invisible compared to Saturn's bling, 13 known rings made of dark particles that barely reflect any light. Through near-infrared observations, you can sometimes spot them as faint lines around the planet. The really wild part is that Uranus's magnetic field is tilted 59 degrees from its axis of rotation and offset from the center of the planet, creating this wonky asymmetrical magnetosphere that tumbles around as the planet rotates. Through supertelescopes, Uranus transforms from a boring blue ball into this tilted, mysterious world with hidden weather patterns and a magnetic field that clearly didn't read the instruction manual. Neptune is the solar system's distant blue giant that absolutely refuses to be boring, despite being nearly 4.5 billion kilometers from the Sun. Through super telescopes, Neptune appears as this deep, vibrant azure sphere, and unlike Uranus, it's far from featureless. This planet is dynamic as hell. The color comes from atmospheric methane, but Neptune's blue is richer and deeper than Uranus, for reasons scientists still debate, possibly involving some unknown atmospheric component. When you observe Neptune through advanced telescopes like Hubble or ground-based adaptive optics systems, you can see actual weather systems raging across this frozen giant. The most famous was the Great Dark Spot, discovered by Voyager 2 in 1989, a massive anti-cyclonic storm system about the size of Earth. But here's the twist. When Hubble looked at Neptune a few years later, the Great Dark Spot was gone, vanished. New dark spots have appeared since then, showing that Neptune's atmosphere is constantly evolving, and these storms are temporary features, unlike Jupiter's centuries-old Great Red Spot. Through powerful telescopes, you can observe white methane ice clouds at high altitudes that cast shadows on the cloud layers below. And you can track the fastest winds in the solar system, screaming across this planet at speeds up to 2,100 kilometers per hour. That's supersonic wind, on a planet that barely receives any energy from the sun. Neptune is generating massive amounts of internal heat. It radiates 2.6 times more energy than it receives from the sun, and nobody is entirely sure why. This internal heat drives the insane weather patterns visible through telescopes. But here's where it gets absolutely wild. Recent research suggests that the intense heat and pressure inside Neptune and Uranus might literally create diamonds. Carbon from methane could be squeezed into diamond crystals that rain down through the planet's interior. Through spectroscopy and computer modeling based on telescope observations, scientists think there could be an ocean of liquid diamond inside Neptune, with floating solid diamond icebergs. Neptune through a super telescope isn't just a distant blue dot. It's a dynamic, storm-racked world that might be producing the most expensive rain in the universe, while sitting in the freezing darkness of the outer solar system. Now let's take a quick reality check and talk about the absolute wizardry that makes these observations possible. Because pointing a telescope at a planet sounds simple until you realize these planets are insanely far away and constantly moving. The Hubble Space Telescope, orbiting above Earth's atmosphere, captures wavelengths from ultraviolet through visible to near-infrared, giving us incredibly sharp images without atmospheric distortion messing things up. But ground-based telescopes have gotten insanely good too, thanks to adaptive optics technology that uses deformable mirrors to compensate for atmospheric turbulence in real time. Basically, they can now match or exceed Hubble's sharpness while being much larger. The Keck Observatory in Hawaii, the Very Large Telescope in Chile, and others use these systems to capture stunning planetary details. Then there's the James Webb Space Telescope, which observes primarily in infrared and can see through planetary clouds to reveal temperature variations and atmospheric composition in ways previous telescopes couldn't dream of. Scientists also use spectroscopy to analyze the light coming from planets, breaking it down into component wavelengths to identify specific chemicals in the atmospheres. It's like reading a chemical barcode from billions of kilometers away. Long baseline interferometry links multiple telescopes together to act as one giant telescope with a resolution that seems almost impossible. And here's the coolest part. Amateur astronomers with high-quality equipment can now capture planetary details that would have been impossible for professionals just a few decades ago. The images you're seeing throughout this video represent the combined efforts of space agencies, professional observatories, and dedicated amateurs who've pushed the boundaries of what's observable. The technology keeps improving exponentially, meaning every few years we get sharper images, better data, and more shocking discoveries about our neighboring planets. What seemed impossible to see in detail a generation ago is now routine. And what we'll see in another decade will probably make today's images look like we were observing through a foggy window. So here's the bottom line. Our solar system is way weirder, more violent, more beautiful, and more bizarre than any textbook ever prepared us for. Mercury is a scarred warrior. Venus is a toxic beauty queen. Mars is a red desert with a watery past. Jupiter is a chaotic storm factory. Saturn has a geometric storm that shouldn't exist. Uranus decided to roll sideways through space, and Neptune is possibly raining diamonds while hosting the fastest winds in the solar system. Through super telescopes, these aren't just colored dots or simple spheres. They're complex, dynamic worlds with their own personalities, weather patterns, mysteries, and stories written in their atmospheres and surfaces. Every observation teaches us something new, answers old questions, and creates a dozen new ones. The fact that we can see this level of detail from Earth or Earth orbit is a testament to human ingenuity, curiosity, and our relentless desire to understand the universe around us. And this is just our local neighborhood. There are trillions of other worlds out there waiting to be discovered and observed. The future of planetary observation is going to be absolutely insane, with even more powerful telescopes coming online, better technology, and potentially even missions that can give us up-close views of the outer planets again. If this video blew your mind even a little bit, do me a favor, smash that subscribe button and hit the bell icon, because we're just getting started exploring the insane realities of space. I post videos breaking down cosmic mysteries, space discoveries, and all the wild phenomena happening in our universe. And trust me, there's so much more mind-blowing content coming your way. Now, here's a question I want you to answer in the comments. If you could observe any planet in our solar system through a super telescope in real time for one full day, which planet would you choose and why? Would you watch Jupiter's storms rage, track Saturn's hexagon, wait for a Neptune storm to appear, or something else entirely? Drop your answer below because I'm genuinely curious what world fascinates you most. Thanks for watching, keep looking up, and remember, reality is always stranger and more spectacular than we give it credit for. I'll see you in the next video, where we'll explore even more cosmic insanity. Peace.